What we want to do is take a look at the gap calculations again. I actually messed them up in the other video for that, and I've got to redo them anyway because we're going to try to bump the blade over a little bit so that the motor doesn't hang out from the side. I don't know if you can see that. It totally hangs out over there and it gets in the way of our supports and a lot of stuff going on. And what that means is if it comes, you know, over to the side, then you've got a bigger piece of wood pivoting from the pivot point, because the pivot point has to be the blade travel path, and I'll show you why. But that means that you have to have a bigger gap. It's basically going to look something like that. The gap on that side will be about that size, 4 1/4 inches, but I'll show you the calculation. Now, the reason we have to pivot from the blade travel path is pretty simple. If we, make this guy pivot from somewhere here, and then the blade path is somewhere here, then if I pivot this way, then the blade path is going to be going through here, and I pivot this way, it's going to be going through here, and you wind up with what's called a sacrificial fence. This is what radial arm saws had. They had the same issue. They had a blade that moved along a path centered on a post mounted behind a table, and then the actual fence. And so it went through at different angles. You had to have sacrificial table and sacrificial fence. You had a lot of capacity and a lot of capability, but you had to replace this sacrificial fence. So in the 70s and 80s, I guess it was the 70s, miter saws came out where they put the pivot point at the center, so that when you pivot, you go through the same point in the fence and the table every time. You have this turntable, but you lose capacity because the radial arm saw was coming from back here, and the miter saw is just coming, way up here. And so the way miter saws fix that is they, came down from above like a giant C-clamp, and that's what makes the thing so heavy, because you have to have this strong base and table and fence, and then the blade needs to be the blades has to come all the way around here and be true and stay at the right angles to all that. Thus the weight and the issues and the expense a lot of times. So I'm trying to get past a lot of that. So I use parallelograms because they can pivot from the rear and maintain the same point where you go through the fence, right? But that means the blade path has to be the pivot point. That's why in the last video you saw a lot of work was done to make sure that it was with some bending of some 1/2 inch rod. Now, what we need to do is figure out the gap calculation, and it's just like before, except the mistake I made. So here's our deal, right? And remember, here's the other side, and it's all closed up. The side pivots from there. This guy's pivoting from here, and to move the motor over enough, we're at 7.75 inches here, and this is our X. It's unknown. Okay, and this is the mistake I made. I drew a line like this and put that at 50 degrees, but really it's 50 degrees off what woodworkers call zero. It's 90 off that, but it's called zero, and that's 50 degrees there. So that's 40, and then in here it's 50 degrees. So see, we got a different angle. We do the calculation, it's X equals 7.75 divided by the cosine of 50, and why don't I do it again? 7.75 divided by cos 50 equals 12.05685. We'll just call it 12, right? Okay, so X equals 12. Therefore, the gap, you just subtract the 7.75 from 12, and you get 4.25. Big gap. How could that be solved? just put a worm drive gear on the saw, and then the motor could be, turned to the side, and it wouldn't have to hang so far. It could be turned forward and backward, and duh. But this motor was, and this blade and all this was retrieved off this table saw, and it wasn't designed for an invention that didn't exist at the time. So hopefully when these are produced, mass produced, they'll have a worm drive setup. But at the current time, I've got to deal with this big gap in the table, and hopefully people will be able to see that it's still a good tool. Alright.